Hello guys, welcome back to another tutorial. Hit the bell icon button so that you don't miss out any tutorial.
Okay, it's time to do some remodeling of our function. We're going to go ahead and take a sledgehammer to it and really only keep some of the basic structures. We're going to do the same things we did before where we detect labels, and then if we see a face, detect a face, and then record all of the information. What we're going to do very differently is create a photo metadata object which will allow us to track all of the information we need all of the way through and then store it into DynamoDB. The way we're going to design this photo metadata object is going to be based on the lessons that we acquired in the last video, where we're going to be thinking about how it's used. So in our case, we want to be able to query out the labels and face labels that have been returned from recognition. So we're going to put that all into an array and use the contains function or comparator later on in the course to get this out and present it as a search engine. So let's go ahead and jump in and see how the restructuring is going to go. So before we go ahead and modify this code into the code that's going to be inserting the information into our DynamoDB, we're going to need an actual table inside of DynamoDB. So here we'll go ahead and create a new table, and we're going to set this up pretty much the same way as we did our test table, except we're going to call it PhotoCloud. We're going to give it a primary key of a UUID. This is just pretty much standard practice. And we will go ahead and change our information here to only require one minimum provision capacity. This is just so we can save a little money and stay inside of our free tier. So let's go ahead and click Create. And then this is going to take us back to here, and we'll use a little video editing here. Alright, and there you have it. We have our PhotoCloud database. So now let's go back to IntelliJ and write our function. Okay, so due to the large number of changes that we're going to need to make to this file, I'm going to try something a little different here. I've already written the file before I started recording this, and what we're going to do now is I am going to compare it to my clipboard. So I copied it in there, and now we have this view. So I find this view pretty useful. It's going to allow us to compare the two files. So I'm going to go through each of these changes and explain what's going on with each one of them. And then we will go ahead and test it out and see how it works. Okay, the first change is pretty simple. I just want to go ahead and include the ability to create UUIDs so that we can create nice, easy to use primary keys for our database. The next change is going to be setting up some additional services that we're going to be working with. So we already had S3 up here, and instead of configuring these regionally one at a time, I'm going to set up AWS config update to region US East 1. This basically makes sure that whenever I call this, I won't have to tell it that I want this specific region. It'll default there. I could still switch this to different regions. For instance, if I wanted to use something in Asia Pacific or on the West Coast, I could override one very specific one. However, we want to work inside of US East 1 for simplicity. And then we want access to recognition and DynamoDB. So let's go ahead and move those over. The next change I made is I simply broke these items into some variables. I had to use them in a few different places, and I didn't want to keep typing this long string everywhere I wanted the bucket name, and this long string everywhere I wanted the object key. So we're going to go ahead and replace the declaration of getting recog and doing the regional specifics, since we did that above, with this. This next change is pretty self-explanatory. Because I have variables now, I use the variables inside of the JOSID packet, so we'll just go ahead and accept those changes. And then this next change down here is to create a photo metadata object. So inside of our previous function, we were getting the information and simply logging it out to the CloudWatch console. So we're going to want to actually structure that data, and the basics of that structure are going to be a UUID for our primary key, and I use the dependency that we had from above, and then the upload is going to be the object key, and then labels is a blank array for now. So the reason I chose a blank array is that there is a contains function. Let's take a quick look at the documentation on that. Okay, here we are at the contains. So it checks for a subsequence or a value in a set. So for instance, if you have an array, you could query, does it have a hat inside the array? Or does it have a tennis racket inside of the array? You could also ask, does it have a hat and a tennis racket? There are several different things you could do with this. You could even check for exclusions. For instance, we could make our search engine use a minus sign between words that we wanted to find. So for instance, you could do something like, show me all tennis rackets that have no hats in the picture. So let's go ahead and go back to our code and see how we're going to finish setting up the insert into our DynamoDB. So we'll go ahead and accept this code change now that we understand why labels is going to be an array. And that's to take advantage of the contains function when we start recalling the data out of it. So next up, I wanted to take our detect label responses and do more with it. For instance, I actually want to store it inside of the metadata, and I want to make sure that the image path inside of the metadata is the eventual place where we're going to be storing the information. So if you see, I actually just took the UUID and then I grabbed whatever file extension was originally on the uploaded object, and I add all of that to the metadata. So we'll go ahead and accept that change now instead of just logging it out. In this next section, I want to go through all the labels just as I was doing before. But this time, instead of just looking for a face to see if I want to run the detect faces method, I also want to check the confidence value of each label. And if it's too low, which so far I've said is 60, I want to return. And then that means just don't process it. This is similar to continue in a normal for loop. From there, I want to take the arrays that we declared above and push onto it the label. This way we have any information inside of this array that we think had a high enough confidence value where we want to add it to our search engine. And then from there, I want to do the same logic as we were doing before, which is detect if there is a face in there, and if so, set this Boolean property. So we'll go ahead and accept that value. And this next one was just a little bit of code cleanup, so nothing really going on there. And down here, more code cleanup. I just switched to single apostrophes for my string quoting. And now we get down to a rather larger change. So what I'm going to do is talk to you about what we're replacing here. So we're replacing what happens with the detect faces. So let's go ahead and move it over, and I'll explain it there so it doesn't have all of this funky highlighting. So here we go. Before, all we did was detect the responses and log it out to the console. So here I wanted to add it to my metadata, much as I did up here where I stored the full metadata for the detect labels response. So now we have all of the data that we've gotten back from the API in our photo metadata, and we've been able to make it more queryable. So here what we want to do is we want to start going through all of the information that it has and make sure that we add that information into the array. So we have a couple of different things going on here. So first, I want to loop through all of the keys. If you look at the structure of the JSON, it just makes more sense to loop through the keys than it does to do this a bunch of different ways. AWS hasn't always been the most consistent with their JSON structures. While it's always well formed and easy to understand, sometimes they use different practices. One time they'll use an array for returning a list of values, and then another time they'll use a key value pair. In this case, they used a key value pair, and this is just the easiest way to handle it. So first, there are a few things I want to ignore. For instance, the bounding box has been stored up here, and we don't need to process it into a queryable format. Same thing with age, pose, quality, confidence, and landmarks. And just like we did before, we want to make sure that we're only including things with a high enough confidence value. In this case, I've left it at 60. And down here, if the key is emotions, we want to process emotions even differently. Yet another different JSON structure, and still different from the way that other attributes for faces and labels were detected. So we have yet another little for loop in here to push the emotion types onto our array if it was high enough. And we created a separate array here for just the emotions. This way we can say, let's look for pictures that just have happy people in it, or, you know, I want to look at people that were excited right now. It's kind of a cool feature, I think. If we keep going down a little bit further, we'll see that I make sure that there's a faces array available if it is not been there. The reason I didn't declare it up above with the labels here is faces will only be here sometimes. So I wanted to make sure that it was optionally included inside of our JSON packet that we'll be storing inside of DynamoDB. And that'll basically wrap it up for that little specific portion of the code. The next big chunk of code that we have down here is all about the DynamoDB and copying our uploaded image into its final home. So let's go ahead and move this over and make it part of our primary function, and let's go over it a little bit. Okay, just starting here from the top, into DynamoDB we're going to put into the table name PhotoCloud Photo, which is actually incorrect. That's what I named it on my development system. And we're going to put the item photo metadata. This should look just like the proof of concept we went over earlier, so I'm not going to get too deep into that. The next thing that we want to do is we want to copy an object. So we need to place it somewhere where it'll be available to be served up to the browser. In the next couple of videos, we're going to be initializing CloudWatch to handle our front end. So I have set up a bucket already in my local system called photoclouddevelopment.gregharrington.com, which is where my images are being uploaded in my internal testing. So what I've done is I have copied it from the source where it was uploaded that we've been using based on those variable names that we introduced above. And then I copy it to a different bucket. This bucket is the public read-write bucket for the entire system of the front-end website. So I make sure that I publish it over with ACL as public read. ACL stands for Access Control List, and this is a way that it says, make this public and available to read, which doesn't allow them to, for instance, change the photo or upload their own photo into it. It's just for this specific object. And then in the end, I want to clean up the object that was uploaded to our bucket in the first place so that we only have one of them laying around. This way, everything is named as we would expect it, because this image path up here came from the UUID and the extension of the object that was uploaded, and we're going to attach that metadata to our photo metadata object up here, which we're storing in DynamoDB. Also, keep in mind we're going to need to give access through IAM to this bucket in our photo cloud policy. I'm not going to go over this in the video since we've been to IAM several times and we have modified the resources. However, if you end up with any questions about the code in this video, please feel free to ask in the comments below. I'll be responding to them directly and personally. Alright, normally we'd test it right here. However, I want to go over one more thing with you guys so that we can make this code a little more generic. Right now, if you were to download this and upload it straight to your system, you would have all kinds of problems and you'd have to make modifications. For instance, this can't be your bucket name because this is my bucket name, and the AWS landscape isn't going to allow duplicate bucket names in between even different accounts. So What we're going to do here is, in the next video, we're going to show how to make some of these things into variables that you can declare right inside of the Lambda function. Let's go ahead and take a look at that in the next video, and then after that we'll go ahead and give this a test. So there you have it. Our photo metadata object came together quite nicely. We optimized certain portions of it so that it would be very performant when we came to scanning and querying it, and other parts we left just as they were. The responses from recognition we kept basically in their raw format. And this allows us to use all of that information. For instance, if we wanted to put a bounding box over a face, we would have all of that information. And it's actually much better left in its original format, since that format is documented within the AWS documentation. So therefore, we don't have to explain why we changed it. The labels, on the other hand, had to be changed so that we could get the performance that we need, and really even make the query in the first place, because the structure that recognition gives us is just not going to be queryable. So as we identified during the video, there's some of this code that I've given you that is basically hard-coded into my environment, and that's not going to work out well for you. So I want to show you how to create some environment variables to make code more portable. Let's go ahead and jump into the next video and check that subject out.
Thank you for watching. Don't forget to subscribe to the channel. If you like the video, do give us a thumbs up and share it. Also check out amazing discounts and offers on our premium courses in the description below.